This is the story about the locomotive that we see on the left, which I bought just really free with the one on the right, which is what I wanted. And this Union Pacific switcher I never really thought of even running. Never modelled American trains, and I just recently decided that, wait a minute, that's a really interesting model. It's tall, thin, it's going to be a real challenge to do what I do with all of my N-gauge or N-scale models, and that is to convert them to DCC sound. Now the Minitrix are good quality, they will run, they're obviously very old. I found out this model's from 1971. I don't know if it's even realistic or if it's got the right number. I can't find any trace on the internet of what is a Fairbanks Morse H-12-44 switcher with the number 3727. I don't know if they were even really genuinely numbered in that series. I don't know if the little headlight cluster and number plate is correct there. I think in real life these things may have had stacks in the UP, little exhaust stacks. But a few things came together and a few compromises had to be made. And this turned out to be a pretty successful project. Minitrix made this model in lots of different color schemes. The one on mine, the price tag on my box is $21 US. Here's an H-12-44, similar model. I had trouble finding pictures of prototypes. Similar but not exactly the same. It's an earlier model of engine. There are the two stacks. The paint on the roof is not so low, the colour is lighter. That could have been the sun. The band is a different height here. The trucks are silver. No headlight cluster or nameplate, number plate. But the headlight cluster was a real problem for me, because looking at these things, and they've all got it, it could have had a white light in it, or a white and a red light, or it could have even had a green light for second portions of freight trains. Probably that thing never existed on any of the real model. So let's just leave it. I'm going to model headlights. I don't have sound. Here is a bunch of Fairbanks Morse dumped in the 1960s at Council Bluffs. Got a few snaps here from YouTube just to see what the paint scheme was looking like. Again, that's an earlier model because it's got the roof overhang. So not exactly the same. And still I can't find a picture of one in the 3700 series. Okay, taking off the body, 2 clips take off the body. You just prise them open here and on the other side, and they are clipping into metal parts of the chassis here. Let's have a look at the chassis. So we have bogies which turn out to have a connection directly into the chassis on one side. So one track feeds the entire chassis is live. That's already a bad start for DCC conversions. That means there's going to be a lot of danger involved in this conversion. There you can see a tab. This is one of the motor connections, and the tab there is pressing against the chassis. There's another tab here that's pressing directly against a plate. That plate is insulated from the chassis, but it has wipers that connect it to the other rail via the other wheels. These areas here are for light bulbs. In fact, one light bulb was still in place, the other one was missing. We're going to use every single piece of space on this model. If we want to convert to sound with lights, we have got to use every single piece of space here. So light bulbs are big, they're a waste of space, they're going to be replaced by nano LEDs. Breaking down the chassis a bit more, so I've taken off the fuel tank. The fuel tank comes on 4 pegs. Pegs go into holes. Those pegs have to be prized open. This plastic is 50 years old, so it's highly likely to break. There are little pegs here. It actually came away without breaking. Revealing 2 wiper pickups. They are from one side, 4 wheels on one side, and they contact this plate. Again, that is an arrangement which requires a lot of space, so the whole fuel tank is hollow just to hide those things. We're going to need to do away with that because we need that space for this conversion. This area here is going to be where the motor control DCC chip is going to sit. In this view, the plates come off. What you can see when I've taken the plate off is that this tab is poking up in this picture. It used to go through that hole and press against this contact on the motor. So it was the other pole of the motor. When we DCC this model, we need to take wires directly to these poles of the motor. One of the first things I had to do here with this kind of design on Minitrix, where the chassis is live, we've got to be very careful. Because if any track current, track voltage, which is 25 volts AC, gets into the orange and grey wires that we're going to attach to these motor connections, that's going to destroy the decoder. What I do is I have a separate decoder for the motor as from the sound quite often, and this is where I'm going to do that because that is actually safer if you destroy the decoder, you've just destroyed the motor decoder, which costs £10 or $10. You don't want to destroy the sound decoder. They're £50 or $50 minimum. They could even be £100 or dollars. So for this conversion, which is in the dangerous category, we are just going to use the sound chip only to drive the speaker. Testing continuity for ohms through the motor at different points on it, I discovered that actually the chassis isn't insulated from the motor casing. Now, the bush connector here isn't exactly in free contact with the motor housing, but there is some path there which could actually destroy the decoder. So if you imagine the chassis is going to be the red or black connection on the decoder, and the orange and grey wires are going to go to these two poles, I definitely do not want the red or black connected in any way to the orange or grey. And there's a kind of weak path through this housing here. So what I'm going to do is I'm going to lift that motor out, place in a thin layer of tape, Kapton tape, which is a very thin yellow insulating tape, and I'm going to press the motor back in, completely surrounded by yellow tape. I don't want any part of that motor or its little bearings, which are here and here, I don't want any part of those touching the chassis at all. This black clip here and this black clip, they pull out towards the camera to release the motor. They also have to be completely covered in Kapton tape before they're pushed back in. That way everything is safe. This whole thing is insulated from the chassis. Okay, taking off the bogies. So there's a pin goes through here which holds the bogie on, very easy to pull out. You pull that out, the bogie falls out, no danger or risk associated with that. On this model, and I'm not sure if I've ever seen that on another Minitrix, the axles actually sit in brass bushes or very simple plain bearings. These were absolutely full of muck, so there's basically, this is sliding on the axle, and of course after 50 years that's full of grease, oil, and oil, if people have used mineral oil, it absorbs water, it goes rusty when they leave it in their cupboard. So these were full of manky, gunked up mineral oil, and I didn't want to take the wheels off these axles. That's a bit risky at 50 years old. So instead I just kind of washed these axles with alcohol spirit. Toothbrush and alcohol spirit. Just brushed them, turned them a bit, brushed them again, got it in there. Seems to be working fine. Taking off the black plastic that holds this on, I should have mentioned, the black plastic that is the bogie frame is held on by this stud at the front of the model. At the back there's a clip. The clip's 50 years old. It's going to break if you have to do that more than once or twice, trying to avoid doing it. You see traction tyres on here. That's a good thing. When you've got a model this big, and we're going to have to use different methods to make space in this model for speakers and chips, and that means making it lighter. These things are phenomenally good. You'll see that I can still pull a 50 car train after this conversion, no problem, and it's thanks to these two tyres. There's lots of modern models also have these tyres, like Kato, Eurostar or TGV. They wouldn't move without the tyres. I've changed them in this instance. These are picked off very easily, and you buy spares on the internet. In fact, now we're going to talk about speakers. So, you ask, how am I going to get a speaker in this model? Okay, class 60 on default volume with the stock speaker. iPad Air. Sounds a lot better already. That sounds really good actually. iPad Air 2. Being smaller, it's quite quiet, but it's got a good tone. Well, when put on a flat surface, that's a lot louder. That's very strange. That'll sound quite loud when it's on maximum volume, actually. But it's never going to sound exhibition loud enough. Whereas the iPad Air will actually sound loud enough in an exhibition. A iPad Mini, which is a really handily shaped speaker. Fits in N-gauge roofs, a treat, the whole thing. Enclosure, 3 little sound ports out the side. I know full well it's got a great tone. When put on maximum volume, it's almost, probably is loud enough for exhibition use. So here we go, one of my favourites. iPad Mini. Cost £3. Superb tone. With my class 31 TTS chip, this is probably one of my favourite locos, with excellent sound. This is the class 60, which is obviously a bit special. It's going to require an extra deep bass tone from whatever speaker you pair with it, which the stock speaker doesn't provide, and the stock speaker won't fit in N-gauge. Let's go. Great tone. iPad Mini, absolutely brilliant, fits in any N-gauge model. Now when I'm testing these speakers, I always solder the wires. I never twist them together, because you can easily make a mistake and blow up your TTS chip which you're testing. So always solder them, don't try and hold them together. Okay, this is 2 speakers out of an iPad Pro 12.7. They're not the base unit, they're the normal unit. 2 of those make 8 ohm in series. Let's give them a go. Probably about the same tonality as the iPad Air, possibly a bit better. Okay, so that's iPad Air Pro. Sorry, iPad Pro 12.7. Okay, speakers. So you've just seen the speaker movie. What I'm planning to do is actually
We'll be using my cranial screw top method of entry into the brain.
the flip top cranial method of Steve Martin, and I'm going to cut the top off this model, and I'm actually going to use the speaker from an iPad to be the roof. I've already got that much clearance. You see this piece of tack here? I stuck that in and I pushed the body back on, and that's how much clearance I've got. My speaker unit is about 5 millimeters, or a sixth of an inch thickness. I've still not got enough, so that only means one more compromise. Not only am I going to have to cut out the roof section, but still, to get the body down, I'm only going to be able to get it to sit on this tab instead of this tab fitting into the slot. So in effect, I'm going to be having to jack your body about 2 millimeters on this model. I actually don't mind doing that at all. If you're looking for space to put in speakers, then go upwards. On some models like this one, that works absolutely fine. No one's going to notice. It actually makes the model look taller, which I prefer, because these 1 to 160 scale models are a little bit on the small side, especially if I run them near European stock. So we've seen the difference in the speakers. For this one, I discovered that the chip I've got is too quiet. It's an 8 ohm speaker, it's going to go with that chip. I'm actually going to use a 5.5 ohm iPad 9.7 Pro speaker. That speaker is not particularly loud. I haven't got really any other use for it. I don't normally take risks with the ohms, because if you go down in the ohms, you are stressing the amplifier in the chip. So 5.5 is as low as I want to go, and on a test it seemed to be okay. The chip didn't get hot, and the sound was slightly louder, about 20% louder, by dropping that from 8 to 5.5 ohms. That'll do. this is how the chip's going to fit. That's the iPad 9.7 speaker there. It's not yet glued into position, it's cut down in length. The main part of it is like a similar to a sugar cube speaker, except it's a long rectangular design, which is ideal for this narrow model. These ports are exactly what come on an iPad, just behind the grillage on the bottom of the iPad. Inside are these speakers with 4 very small ports like that. Yeah, people looking at this model when it's running are just going to have to imagine that these are special air intakes. Here I've marked what's got to be chopped off to make room for the speaker. There's the speaker, in fact, above. It looks too big. Here you can see how much I had to cut off the speaker. These speakers are designed with that size of chamber. It's normally about, let's say, half a cubic inch or 4 cubic centimeters at the most in most tablet and iPad speakers and laptop speakers. That seems to be the ideal size of the chamber. You can cut bits off. You've got to fill it again with a rigid plastic, not with a tack or anything soft or rubbery. You've got to fill that with a rigid, and I use a car body filler, an automotive car body filler. Inside this one is actually a foam, an acoustic foam. The point of that foam is to increase the surface area and create a resonance, a resonant chamber. So the foam's still there. I just had to obviously cut the foam off where I've made the cut there after this picture was taken. And then I've filled it with a small amount of car body filler, but I've still got almost the rest of the thing filled with the special foam. This tab here is the electrical connections. The blue part's going to be ground off the top of this model. I don't want to grind this whole of this top bridge off the model, because if I do that, when I put the motor back in, it's quite likely the chassis would snap. So I want to keep the rigidity of the whole thing. In order to keep that bridge there at the top, I can't actually get the speaker down as much as I'd like to, if you see what I mean. So on this picture, that tab is actually just above the point it should click into. I'm going to run it like that because, as I say, if I really wanted to lower this body down to the same level as it was from the factory, down and to the 2 or 3 millimeters lower than I'm going to, I would have to completely remove that top part of piece of metal there, and I don't want to do that. So I'm making a compromise. I'm going to jack your body very slightly. Underneath the decoder here you can see underneath the fuel tank, this is the motor decoder. So I've got my orange and grey connections going to the motor there. I think at this point I've still got the tabs on the bogies, but I'm actually going to cut them off because I've got rid of the wiper mechanism. So I'm going to cut off most of these tabs off the bogies and wire a wire directly to that, which goes around the bogey tower to give it loosely around the bogey tower and back to this chip. And that wire coming from these two tabs is the black wire. The red wire I'm actually going to stick in this hole here with a brass. I'm going to make a piece of brass that just shoves into that hole, and that actually is the left, you call it rail connection. This whole decoder is going to get covered in Kapton tape, it's going to be glued down, and then it's going to have the fuel tank stuck back on top of it, just glued on top of it. That way there's no way of getting any short circuit. I changed this chip. This is an ancient lens chip. I actually didn't use that one. I used a modern chip which didn't have this separate package here. This is the sound decoder. I just picked this up in an auction. I never even thought I'd use it. And then one day I thought, wait a minute, this square shape fits perfectly in the cab of that H-12-44. I'm going to shove it in there. So where that's going is here. It fits perfectly widthwise in that cab, and I've just had to shave off probably about 3 or 4 millimeters, either 5 millimeters of metal. I've had to grind off the back of this thing, which was solid except it did have a hollow section at the top. So I've ground that off to make room, and that will just slide into the cab. It will take its red wire connection directly from the chassis by plugging into where the light bulb used to plug into, here. Go back to the chip. That's the little brass tab I've made that's going to plug into the old light bulb holder. The black wire, which is here, is going to go all the way down to those bogies. This chip, as is common with many chips, these things are so badly designed. It was delivered without wrapping, and during handling all the wires snapped off it. So the red and black track pickup wires snapped off it, and also there are capacitor wires here and here. They snapped off it as well during handling. How these companies expect people to fit these things without snapping the wires off, I do not know. I mean, I bound this thing up in Kapton tape before I even started handling it, and I still snapped off the wires. So I had to take the tape back off in this picture to resolder everything. I actually, looking at all of this under the microscope or magnifying glass, I discovered that the sound speaker wires, that's these two here, also had bad frayed ends from old age, and so I completely resoldered them back onto the chip, which is scary business. So that's prior to fixing the chip, and that's where it's going to go. This is the capacitor for the chip, which keeps it alive for a fraction of a second when it's going over point work, etc. What you can see here is stage 1 of the protection, but that wasn't adequate. This is protecting the orange and grey wires from track voltage, but that wasn't enough. When I checked this before I ran it with the multimeter, I discovered I'm still getting, or would get, current into these parts of the motor housing, and maybe that's going to get into these wires and destroy the decoder. So actually I filled this whole area with tape, yellow tape, after this, and refitted that motor. We'll see that in a later picture. Okay, in this stage I've wired the speaker to the chip. I've also painted some primer on the speaker as well, because it's actually going to be the roof. It's still not ready to run. I'm going to make some more modifications. Another view of the speaker there. Very simple tabs here, which in the iPad they're just gripped by some sort of compression fitting. Here you can just solder straight onto those tabs. Here's the chip in position. Here's a resistor for the lights. We'll come on to the lights in a minute. And this bit area here I changed after this. We'll see that in a minute. Okay, top view. There's the hole I've had to make for the speaker. That actually became a bit of a problem because I had to then thread this speaker through that hole. Which was a difficult handling exercise. When you've got all these fragile wires, you could well break stuff. Let's look at the lights. So we have nano LEDs. These are like the size of a pinhead. They come with copper enameled 0.1mm wire. It's amazing stuff. It looks like it's bare, but it's not bare at all. And in fact, you can press it together incredibly hard and it will not conduct. It is an incredible coating. In the manufacturer's instructions it says you can burn that off to solder it. I never found that to be successful. I found you actually have to file this coating off very gently with a tiny file, like a nail file that you'd use for your fingers. Once you can get solder to adhere to it, then it's ready to solder. There's a nano LED in position. But this time I tried to also have a headlight or a marker light at the top, and I wanted that to be red-white. But the soldering just got too much. I just had so much to do and it was getting a mess. So at the end of the day I pulled this one out. I didn't use it. I've just got a simple, nice, natural yellow headlight. Same on the other end. This is fixed down with Yoo-hoo adhesive. Very, very sticky. When you try to pull the wire off, the Yoo-hoo is so strong you possibly break the wire. These wires are quite strong. They're impressive. They're single strand, but they're strong. One of the downsides to them is they're very springy. They won't stay flat. That's why I've had to use this glue to hold them in place. Here's a solder on a coupling, a 0.1mm wire. So that there looks like it's bare. It isn't. It's coated with enamel. Here at the end I've just filed it until I can see a slightly different colour of copper. And there's a resistor in the jaws there. And I've soldered that onto the resistor in a quick movement. And that there you can see there is flux. And just after this I will wipe that off with alcohol cleaner. These are nano, well, quite small resistors, but this is nano wire. In this picture you can see that I've now put more Kapton tape. The motor is now sat in Kapton tape. Okay, at the front end, what I discovered was that and again here's that tape, that's that tape that the motor's now sitting in its bearings. They're all pressed into that tape. That worked. At the front end, at the front end, I decided to beef up the capacitors, so I bought tantalum capacitors. They are 16 volt capacitors, and when I looked at the old one that I took out, it's a 10 volt. So actually, when I measured what the decoder was producing, it's producing 5 volts. So there's no problem to use a higher voltage capacitor. It's not like the thing is actually going to spit a higher voltage back at the chip when it's in use. It just puts back to the chip whatever the chip fed to it, 5 volts. Arranged these parallel. I'm not showing the wiring here, but what I've used in this black wire here is actually the black feed to the sound decoder, and that's going down to the bogies. This is a different kind of wire that I'm using here. This is from a printer, dot matrix printer cable, like an IDE or an IDE cable as they're known in the computer industry. And I've just peeled off one of the 21 wires that are in that flat cable, and they are really useful because they conform to shapes. So like here, I've pressed that into this channel and it's just held it perfectly, and I used the same wire later on to run through this channel. You've got to use everything on models of this size. I pressed that wire into this channel and it stayed there nicely. So that's a dot matrix printer wire, which will give you an infinite supply of black, a very useful tiny diameter wire. Once again, here we are fitted up now. Speaker is almost in position. My cut was rough where I've made a place for the speaker. That turned out to be a problem because when I glued the speaker in with Yoo-hoo, I had little rubbery blobs of it sticking out here and here, and when I came to fill the cracks with filler, the rubbery blob bits couldn't be filled. So what happened was I've ended up with a kind of visible groove there. Here we are, so now it's glued in position. This is the rubbery crack I'm talking about there, damn that. Here I've used a car body filler, cheap, like 2 pounds of it, or 1 kilo of it is like £10 or $10, last you forever. Stuff's brilliant. This actually came out better than I thought, because I thought, going back to the other picture, I actually thought I'm never going to be able to restore the slight curve on that roof. You see this piece here? I always keep the pieces. That's the curve on the roof. This is the piece I've cut out. I thought I'll never be able to restore that. I'm going to end up with a, you know, a flat this. People are going to see that. But no, actually, building that up with the car filler, which took literally 5 seconds, worked really well. And then I just simply got this small file, and this is the same file I used for taking the enamel coating off the 0.1mm wire. So I just ran that file along and actually it came out curved pretty good. I can't complain about that. But I had a couple of areas where there was rubbery glue here and here, and I just couldn't get that right, so never mind. What could have happened to this model if I hadn't done this job? It probably would have ended up in a dustbin. Then I wanted to paint the roof. Saw this model, I thought, yeah, I like that shade. Slightly darker than the original. This looks more like the livery that mine's meant to be. Whether mine really ever carried this livery, I will never know, because I cannot find for the life of me any photo of a loco in this series. Oh, you'll see at the cabin there used to be a headlight cluster here, possibly multicolored, red, green and white, who knows. This would have been the number plate. I was going to illuminate these, I was going to illuminate the cab, and I did, but the wiring just got too much and I couldn't get the body on. So at the end of the day, all we've got is a nice bright daylight yellow, I'm sorry, not daylight yellow, natural yellow nano LED. I actually purchased those from China. You simply search 0.1mm LED, and you'll find them. So yeah, I thought I'd copy this colour. That was a piece of cake, black with a bit of white in it. Spray painted the roof. Came out nice, like that. One thing I remembered here is that my spray gun, and I don't know if this affects other people, I cannot spray enamel paint. It has to be acrylic paint. And I like Tamiya paint. So Tamiya acrylic, sprayed great. Enamel just blocked up the spray gun. Maybe that's obvious to everybody. Repainted the little horn in silver, repainted the bell at the other end in gold. I left this little piece of blemish here. I thought that's quite realistic, you know. But in this view here, everything's in. So the chip's in there behind the windows. Yeah, you can't hide it, but so what? At least the thing's got sound like a similar sound to an HO scale model, and it's a tiny little thing, fits in your head. I hope that's useful. I'll leave you with this picture which I found on the net, thanks to whoever painted that. It's beautiful.